Assalamualaikum and salam sejahtera. Okay, so today I would like to discuss about our exercise 3 on single phase circuits. Okay, so this is the list of important formulas just as you for you to remind and use and the remaining of the slides to solve the exercise 3. So the first one so is the XC. The XC must be in ohms. So which is equivalent to 1 over omega C. The next important formula is SL. The way to find is by multiply the omega and L. And then the impedance is R plus JXL minus XC. And then from here also we can get the IT, which is the IT is equivalent to V divided by ZT or Z total. Okay, so the others important formulas that you must remember is P is equal to VRMS times IRMS, which also equivalent to V squared RMS divided by R, which is also equate to I squared RMS times with your R. Okay, so depends on the information given, so you can use which one is suitable in order to get your real power or P, and the unit is in watt. Okay, so about the next one is the reactive power. The reactive power is V times with your I, which also equivalent to I squared X, and also you can find from V squared divided by X. So the X value here is depend whether your reactance is from the inductor or capacitor. Okay, the last one is the apparent power. Okay, the apparent power here is equivalent to V times with your I conjugate. I conjugate here means whatever or the current that you found here, you must have the opposite of the J terms or opposite in your angles. Okay, so now we go to question 1. Okay, so question 1 is the question is about a coil of resistance. You have the coil of resistance of 8 ohms. Inductance of 150 millihenry is connected in series with the 100 microfarads capacitor across a 240 volt with 50 Hz AC supply as illustrated in the figure 1. So you have to calculate the impedance of the circuits. The question also want you to get the current supply or I here, and the voltage across the R, L, and C. The final one you have also to you must also determine the phase angle between the current supply, voltage using the impedance or the voltage triangles. So we go to how we're going to solve these problems. So in first place, the question asks you about to get the impedance of the circuits. So since the circuits are in series, we have a series circuits here, and all this value, the R is given as 8 ohms, L is given as 150 millihenry, capacitor at 100 microfarads with your V is equivalent to 240 with 50 Hertz. So in a way, to find the impedance, we know we have the inductor and capacitor here are all in series. So definitely in order to get the Z or the impedance is R plus JX. This X is XL minus XC. So we know that our R is given as 8 ohms. So XL is formula is represented also can we get from 2 pi FL in ohms. So what we have here, the L are in Henry, so you have to find, okay, the reactance, okay, in ohms value. Okay, so yeah, by using this formula 2 pi, okay, you use the frequency at 50 hertz, okay, with your given inductor, okay, at 150 milli. So finally your XL is, okay, from the calculation, okay, so your XL, okay, is determined at 47.12 ohms. Okay, so the next one, since we have the capacitor here, so of course we have the uh, capacitance, okay, the reactance of the capacitance, okay, which can be found from this formula 1 over 2 pi fc. Okay, so 1 over 2 pi times 50, okay, and your capacitor is given as 100 microfarad. Okay, so the answer will be, for your reactance of the capacitance is 31.83 ohms. Okay, and then you put all this formula into the impedance. Okay, here the R plus Jx minus Jxc. So the Z is now equivalent to 8 plus 47.12 ohms minus J 31.83 ohms. Okay, and then your Z is 8 plus 15.21 ohms in complex or representation. Okay, but okay, but the magnitude for your Z is only 17.26. Okay, in order to find the magnitude, so you have to convert, okay, this imaginary form of Z into the polar form. Okay, so the next one, okay, is to find the supply current. Okay, so since your currents, okay, are in series, okay, so directly you can find, okay, the V divided by your magnitude of Z. So your I magnitude, okay, is 13.91 ampere. Okay, so the question also, okay, want you to find the voltage across the R, the L, and the C here. Okay, so the V is equivalent to IR. Okay, so your I, okay, your I that you found previously, okay, times with your resistance value here, and then you get about 111.28 volt for your voltage across your resistance. Okay, the voltage across your inductance, okay, the formula is I times your XL. Okay, so your I is 13.91, the magnitude of I. Okay, and then you get the XL, okay, as 47.12. Okay, you multiply these two terms together, okay, will give you the answer, okay, at 655.44 volt. Okay, so the VC is I times XC. Okay, so the same I here, since they are in series. Okay, the I are in series, so 13.91 times with your, okay, XC at 31.83. So the voltage across your capacitor is 442.79 volt. Okay, so now we proceed to the next question. Okay, so you have to find the phase angle between the current and the supply voltage. Okay, you can either, okay, using the impedance triangle or the voltage triangle. Okay, if you want to use the impedance triangle, okay, the R are in x-axis, okay, and the X are in y-axis. Okay, so the summation of R and X is your impedance, right? Okay, so the cos theta is equivalent to the opposite of the angles divided by the behind of the angles. So you get R divided by Z. Sorry, the cos is the behind angle, okay, the behind side of the angles, okay, divided by your hypotenuse, okay, your Z. So R divided by Z, which equivalent to 8 divided by 17.26. So you get the cos theta, okay, or the power angle, the phase angle between the current and the supply voltage is 62.38 degree. Okay, so you can also have your cos theta, okay, by using, okay, the voltage triangle, okay, which from the voltage triangles your VR are in the x-axis and your VL minus VC, okay, in your y-axis, okay, and the summation of this you get the V supply. Okay, so the cos theta is VR divided by PS is 111.28 divided by 240 degree. Okay, also give you 62.38 for the power factor. Okay, so this power factor is also the angle between the current and the supply voltage.